Hello, class. This is Precalculus, a special snow day episode. Today we're going to be looking at the second half of section 6.5. Get out your notes that look like this if you have them. If not, just write on a piece of paper. I'll be writing on this blackboard here. Okay, so if you remember the first part of section 6.5, we were looking at complex numbers, which in standard form look like a plus bi, and we were writing them in what's called trigonometric form. R, the modulus, times cosine theta, the argument, plus I sine theta. Okay, today we're going to be looking at what happens when you multiply and divide these complex numbers, particularly when they're in this trigonometric form. So we're going to be multiplying two of these complex numbers together, which we're going to represent both with the letter Z. So to sort of make it easier to tell the difference, we're going to mark them with this subscript. So this will be Z sub 1 with R sub 1 and theta sub 1. And this will be Z sub 2. Okay, and we're going to look and see what happens when I multiply these two together. So I'm just going to write out, or I'll just do it here. If we've got, for multiplying this times that, the easiest thing to do first is to multiply the two r's. So r1, r sub 1, whoops, times r sub 2. But now we've got to multiply the trigonometric parts, and we're going to have to FOIL this. So we've got cosine theta sub 1 times cosine theta sub 2. Then we've got cosine theta sub 1 times I sine theta sub 2. I'm going to write that with the I in front. I cosine theta sub 1 sine theta sub 2. Now I move to my second term here. I sine theta sub 1 times cosine theta 2. Just for the space reasons, I'm going to write this down here. Plus, and then finally, I sine theta sub 1 times I sine theta sub 2. So that'll be I squared sine theta sub 1 sine theta sub 2. Now that certainly looks like a mess right now, but there is a bit of order in there. We can see if we kind of can consolidate some of this. I'm going to take the cosine theta sub 1, cosine theta sub 2, and the sine theta sub 1, sine theta sub 2 parts, and I'm going to write them together here. So we've still got our R1 times R2, but inside the parentheses here, we're going to have cosine theta sub 1, cosine theta sub 2, and then the I squared, of course, is negative 1. So this is really minus sine theta sub 1, sine theta sub 2. Okay, that's that part. And then get another color here. Okay. The terms with I in them. We're going to take those and consolidate those. So this will be plus I times cosine theta sub 1 sine theta sub 2 plus I times sine theta sub 1 cosine theta sub 2. And we can close those parentheses. And of course, we've still got R1 times R2 on the outside. Now that still looks like a mess, but then you can remember, if you look at this, that should look sort of familiar. That's the right hand of the sum identity for cosine. So that, what's in yellow that I've circled, I can more compactly write, I'll do this in yellow again, can more compactly write as cosine of theta sub 1 plus theta sub 2. And then for the blue terms, there's an I uh, in both terms. So I'm going to pull that out front. It's going to be I, and then this part that's left over, cosine theta 1, sine theta 2, sine theta 1, cosine theta 2. That is actually the right side of the sum identity for sine. So this is kind of a cool place where those sum and difference identities pop up and actually simplify things. So that compacts into this, and of course we still have the R1 sub 1 times R sub 2. So once we've done all that, we've got a nice formula for multiplying two complex numbers in trigonometric form. This is sort of a catchy formula. It's just the product of the two moduli, I guess, and then the sum of the two arguments inside there. So that makes it really easy to do the type of problems that we're going to look at next. Okay. So the example given in the notes is we've got two complex numbers, a z sub 1, which is 2 times cosine 2 pi over 3 plus I sine 2 pi over 3. Our second complex number, 8 cosine 11 pi over 6 plus I sine 11 pi over 6. Okay, we want to multiply these two. So the product, we multiply R1 times R2. That's 2 times 8 times, and then we can use the formula here, just add the two arguments inside of cosine. That'd be 2 pi over 3 plus 11 pi over 6 plus I times sine of 2 pi over 3 plus 11 pi over 6. There you go. Now that's the product, but of course we can simplify that a little bit. So what I'm actually going to do is I'm going to take this the sum of these angles that we've got, 2 pi over 3 plus 11 pi over 6, that shows up twice like it always will. So let's go ahead and just add those as a sort of side problem. It's adding fractions, so common denominator, 4 pi over 6 plus 11 pi over 6, 15 pi over 6, which reduces to 5 pi over 2. So I could write this as 16 times cosine of 5 pi over 2 plus I times sine of 5 pi over 2. That's the product in trigonometric form. If you want to write the product in standard form, then you just evaluate cosine and sine of 5 pi over 2. 5 pi over 2 is coterminal, of course, with pi over 2. So cosine of pi over 2 is 0, and sine of pi over 2 is 1. So another way to write this would just be 16i. So that's the product. That actually is a lot easier to visualize than this, but what that looks like if you're thinking about the complex plane is, the point on the imaginary axis here with coordinates 0, 16.